Good afternoon, welcome to GWA Physics, and the problem that we're about to work has to do with the simple machine of first class levers. Okay, on a first class lever, like some of the other simple machines, it has a special mechanical advantage. The mechanical advantage on levers deals with the idea of lever arm, and lever arm of the effort divided by the lever arm or the resistance. The lever arm is defined as the distance from the fulcrum, we'll label that fulcrum, to where the force is being exerted. So if this is at 5 centimeters here and that's at 70, then from here to here is 65 centimeters. And that would be the lever arm for the effort. And the lever arm for the resistance, which is the object, goes from the fulcrum over to where that force is being applied, and that is 25 centimeters, and that's the lever arm for the resistance. So in our mechanical advantage formula, it says that the lever arm for the effort, which is 65 centimeters, divided by the lever arm for the resistance, which is 25 centimeters, will give us the mechanical advantage. And 65 divided by 25 is 2.6. 2.6. So the mechanical advantage for this particular lever is 2.6. If we move the fulcrum closer to the weight, the mechanical advantage gets greater. If we move the fulcrum back closer to the 50-50 mark, then the mechanical advantage approaches 1. Now, we still have the other mechanical advantages, the two that are most common to all the simple machines. Mechanical advantage is equal to FR over FE. And remember, we're putting this over 1. And the mechanical advantage over 1 is equal to DE over DR. Now, what that allows us to do is solve for the forces necessary to make these things move, or it allows us to solve for the distances that those objects or forces will move. So let's give this a value right here of 10 newtons. And we're trying to get this block to move a distance of 5 centimeters. Okay, so if this is the object, then this would be F of R, which is the weight of the object, and the 5 centimeters would be dr, which is the distance that the object moves. Now, what we don't know is what is the force going to be measured on the spring scale, and second of all, how far are we going to have to pull down on the spring scale to make this object move 5 centimeters. But we can use these formulas right over here to solve the problem. Let's look at that more closely. First of all, the mechanical advantage is 2.6. So we're going to plug in 2.6 in both places where the mechanical advantage is. Second of all, we have FR is equal to 10, and we don't know what our effort force on the spring scale is going to be. Second of all, we know that the object is going to move 5 centimeters, and we do not know the distance that the spring scale is going to have to move down there on the other end. But we can use our algebra and solve for that. Let's do the top one first. If we cross multiply like this, we're going to get 10 is equal to 2.6x. Well, 10 divided by 2.6 is 3.85. So in that situation, the force over here, this spring scale, is going to read 3.85 newtons. Secondly, if we cross multiply again, we're going to get that x is equal to 2.6 times 5. So 2.6 times 5 is 13. So we're going to have to pull down on this side 13 centimeters in order to get this side to move up 5. based on the mechanical advantage. If you have any questions, see me. Otherwise, thank you for watching.